So, hello, we are going to go over slides 14 and 15 on week 13's online live notes. So, we're given parabolas in different formats, and this particular format, y equals a parentheses x minus h, so that quantity squared plus k, is called vertex form. So it kind of looks kind of scary, but as far as graphing it, I think we're going to maybe kind of like the way this comes out because the vertex is literally right here and right here. So if you have a parabola that is written in this format, we can take the opposite sign of whatever the h value is in that equation, and then we can take whatever k value they have. So we have an example problem, y equals 3 times the quantity x minus 2 squared minus 7. And I'm just putting some notes here. This is a parabola. We know that because it's x to the second power. In this form, it has the vertex at hk. And what I have put down here is think opposite sign of h, no change on sign for k. So I'm going to see if I can try to explain that maybe a little better, hopefully. So this is the standard format of a parabola written in this special vertex form. And I'm just going to duplicate this example problem right below it so we can kind of match things up. So notice our A value is 3. Our H value is -2. But because the standard equation has a negative sign in front, that negative and that negative is going to make that a 2. So a +2. So it's the opposite sign of whatever the h value is. So our h happened to be -2, so we're going to go with the opposite sign, which is 2, or think about it as that negative times that negative is going to make that a positive. And then k, we're just going to take the k. The k is right here. So let me circle. Here's your h, and here's your k. So k is -7. So that is your vertex. All right, that's that turning point, whether it be a minimum or a maximum. So because this has a positive a value, we know this parabola is going to face up and you're going to have a vertex right here, and it's going to be at a minimum. Okay, so let's go ahead and make a little XY chart. And the reason that I do that is because in this program we're working on, they want us to plot 5 points on the parabola. The vertex, which we just found, 2 points to the left and 2 points to the right. And then we're going to click on this graph a function button. So I'm going to make my table a little longer here. I'm going to put the vertex in the middle of my table. So 2 and -7, and then I'm going to graph that. So I'm going to come over 2 and down to -7. So that's the vertex. And remember, we just got that right from the equation that they gave us. So vertex, that is our minimum. Okay, now we have to graph 2 points to the right and to the left. So let's look at x values to the right of x is 2. Well, we could choose 3 and we could choose 4. Those are x values to the right. So let's choose 3 and 4. And then x values to the left, maybe we could choose x is 1 and x is 0. Okay, so we've got these are going to be to the left, and these points are going to be to the right. All right, so now it's a matter of order of operations. We're going to start plugging in these x values. Let's start with the positive ones here, the 3 and the 4. We're going to put them into these equations. So we're going to actually solve that equation 4 times to be able to figure out what y is. See, this is saying what's y when x is, well, let's try 3. So y is equal to, we're going to use our formula here that they gave us, 3. Now we're going to plug in for x, we're going to plug in 3. Minus 2 is still part of the formula. We're going to square it and we're going to take away 7. So order of operations, we want to take care of the parentheses and exponents first. So 3 minus 2 is 1. 1 squared is 1 times 1 is 1. 1 times 3 is 3. And 3 minus 7 would give us -4. So when x is equal to 3, the y value is -4. Let's try it again with 4. So y equals, we're going to write the equation again, 3. This time we're going to put a 4 in for x. 4 minus 2 squared minus 7. So try pausing the video and see if you get the same thing that I'm going to get, hopefully. Hopefully we match. Okay, so if you're back, I did 4 minus 2, which is 2. 2 squared is 4. 4 times 3 is 12. 12 minus 7 is 5. So if you got a 5, you are on the money. Now we could graph these. So 3 and down to -4. So over to 3, down to -4, and then over to 4, down to 5. So over to 4, I guess we wouldn't be go down to 5, we'd be going up to 5. So 1, 2, 3, 4, 5, something like that. Okay, now let's try putting a 1 in for x. So we're going to go at this again. So y equals, we're going to write the equation out. We have 3, we're going to plug in a 1. We plugged in a 3 and a 4, we're going to plug in a 1. Okay, so pause the video and see if you get the same thing I get. So if you're back, 1 minus 2 is -1. -1 squared is -1 times -1, which is 1. 1 times 3 is 3. And 3 minus 7 would give us a -4. Let's try it again with 0. 0 is great. So we're going to do 0. All right, so pause the video and let's see if we get something out that's the same. Okay, so 0 minus 2 is -2. -2 squared is -2 times -2, which is 4. 4 times 3 is 12. 12 minus 7 is 5. Okay, so you might start noticing there's a pattern going on here. All right, so that's kind of something to kind of keep your eye out for. Let's graph this. 1 and -4. That looks very symmetrical to that. And 0, 5. All right, now we'll click on this graph a function button, and it should draw kind of a skinny little parabola, just like that. Okay, and that should satisfy the workload for this particular problem because we have graphed the vertex, which we caught that from our HK, and then we just substituted in some x values to the right and some x values to the left to help give us the actual shape, the correct shape of that parabola. All right, let's try one more. So the last one, they're going to give us this parabola in standard form. So standard form is y equals ax squared plus bx plus c. Okay, so our practice problem is y equals x squared minus 10x plus 20. So right off the bat, we know that this is in descending order. We have our squared term, our term that's not squared, and our constant. So if we wanted to, we could write this standard form right below this, y equals x squared plus bx plus c. Okay, now if we were going to use the quadratic formula, we would know that our a value is 1, right? So that should be ax squared. Our b value is -10, and our c value is 20. But they're not asking us to find where the parabola crosses the x-axis. They want us to plot 5 points on the parabola, the vertex, 2 points to the left and 2 points to the right. So we're going to end up having to make a little table again. But I have a little note here. When you see a parabola written in this standard form, you can find the axis of symmetry as using this little baby formula here, this x equals -b over 2a. So that'll help us find our vertex because we know the axis of symmetry goes right through the vertex. So our b value, we're going to need that is -10, and our a value we know is 1. So our axis of symmetry is x is equal to negative sign, and then we have b, which is -10, over 2 times whatever a is. Well, our a is 1. So x is equal to, that negative times that negative is going to make that a positive 10. 2 times 1 is 2, and 10 divided by 2 is 5. So our axis of symmetry is x equals 5. That's also the x coordinate of your vertex, right? So this is your vertex here, or at least it's half of it. So let's put a 5 here so we can be ready to plot our points here. Okay, so we know this thing has a line cutting it in half at x equals 5. So we're going to find x equals 5 right here, and we're going to do a dotted line here. That sort of will help us as we figure out what this thing looks like. We know it's going to face up because our squared value term has a coefficient that's positive. Okay, so if we know x is 5, let's put that into this equation and figure out what y is. So y is equal to, well, we're going to put a 5 in for x. We're going to square it. Take away 10 times the 5, because we got to put 5 in again twice, plus 20. Okay, so pause the video and see if we get the same answer here, then come back. So we're looking for y when x is 5. So 5 squared is, I'm going to need to write this out here, probably 25. Minus 10 times 5 is 50 plus 20. Okay, so 25 minus 50 would be negative 25. And negative 25 plus 20 gives us negative 5. So now, hopefully you got that. We can graph that vertex. So we're going to come over to 5 and down to negative 5 right there. So that's going to be our vertex. Okay, we need 2 points to the left and 2 points to the right. So to the right, we could go with x's, let's see here, 6 and 7. Let's just try those. And maybe to the left, we could go with x is 4 and x is 3. And we'll see if there's another pattern that happens here. All right, so we're going to have to do this order of operations a few more times. So y equals, we're going to put a 6 now in. So 6 squared, I'm putting that 6 in for x. I'm going to put the 6 in again there. Minus 10 times 6 plus 20. Let's see what that delivers to us. All right, pause the video. You know the deal. Let's see if we get the same answer. Okay, so if you're back, I know that 6 times 6 is 36, minus 10 times 6, which is 60. So I'm looking at 36 minus 60 plus 20. So let's write that out. 36 minus 60 plus 20. So remember, with order of operations, you're allowed to move left and right as long as you're working with positives and negatives, right? So 36 minus 60 plus 20, that should give me a negative 4. So I can come over to 6 and down to negative 4 and graph that second point. Let's do it again with 7. I'm going to again put that 7 in twice. All right, and then pause and let's see if we meet up, see if we match. Okay, so 7 squared is 49, minus 10 times 7 is 70 plus 20. Okay, 49 minus 70 plus 20 should give us a negative 1. Let me just double check that. 49 minus 70, oopsie, plus 20, yeah, negative 1. All right, let's graph that. So 7 and negative 1. Okay, now we could go through this again with using 3 and 4, but we could also use the fact that we know that a parabola is cut exactly in half by this axis of symmetry. So we can kind of use that to our advantage without doing the actual math here. So if you come over, we came over to 6 and drop down to negative 4. So if we come over to 4, we should also be able to drop down 1, 2, 3, and down to negative 4, right? That should be negative 4. So that means those are, they're like mirror images of each other. And then if we go down to 3, we should be able to drop down to negative 1. So come over to 3 and drop down to negative 1. That makes that point the exact same distance, basically 2 bunny hops to the right, and then we're going to go 2 bunny hops to the left. So that's a negative 4, and that's a negative 1. If you feel uncomfortable doing that, there is no problem at all with you just putting these into the equation. So let's do that. So y equals, we'll put a 4 in. 4 squared minus 10 times 4 plus 20. Let's prove that that became negative 4. So 4 squared is 16 minus 40 plus 20. Okay, 16 minus 40. it's going to be negative 24 plus 20. That gives us negative 4, so that checked out. And we could do the same thing with the 3 here. So y equals 3 squared minus 10 times 3 plus 20. So pause this and let's see if you get a negative 1. So 3 squared is 9. 10 times 3 is minus 30 plus 20. So $9 minus $30 means we're broke negative $21, but we find 20 bucks and we pay ourselves back, but we're still negative 1 or a dollar short. So we can now click on this graph a function tool and it should come down and make a cute little parabola just like that. Okay, so these do take a little bit of time for sure. If you have a graphing calculator, I'll show you how to do these on your calculator. I'm just gonna work on the one that we have here. So I'm gonna go to the y equals button, clear out anything I have in there, and I'm gonna put this problem in here. So this is x squared. So x is right here, x right there, x theta. I'm gonna go up and square it using my up and I square. I'm gonna use my right arrow to come down, minus 10, again, x plus 20. All right, I'm going to graph it just to see if it looks similar to what we just graphed. It should. Yeah, okay. And then you can hit the second button and the graph button. It'll bring you to the table and we can double check our values. So let's do that. So when x was 3, we found that, oh, there's a glare on there. We found that y was negative 1, right? When x is 4, we found that y was negative 4. We keep going, 5, negative 5, 6, negative 4, and 7, negative 1. So these graphing calculators, can really help you out. These are not required for the course because they're expensive, but if you have one, you might as well use it. All right, so was that it? Oh, okay. Yep, so email me anytime, jessica.a.parcell@wilmu.edu, and we will say a final goodbye. Let's see here. Where is he? There he is. That's Hank Williams Jr. right there. He always wants to help out with our math videos. So, Hank, this was so boring you actually fell asleep. All right. Good luck, everyone. Hank says, good luck out there. Bye.